one more foundational series here that we're going to look at. It's called the geometric series. So a geometric series has a ratio. Geometric means multiplying when we're talking about series and sequences. So what it means, we're multiplying by a ratio r. So it looks like this. Here is the form of a geometric series. This is going to be a very important one. We have a, which is some starting value, times a r, so our ratio, to the nth power. So the first one in is 0. Now notice, by the way, this one starts at 0. So that when this is 0, we plug in 0. R to the 0 is 1, so we just get a. Plug in 1, we get a times r to the first, ar to the second, ar to the third, and eventually ar to the nth, and so on and so forth. So we have this very useful theorem here for geometric series. Once we can tell that it's geometric, we can see that it will diverge if that ratio r is greater than 1. If that ratio is between 0 and 1, then it will converge. And we know what it converges to, and this is a very important one. It'll converge to a over 1 minus r. Again, this is only if the ratio is between 0 and 1. Well, let's check it out and see how this works. Okay, so a little proof first of all. So suppose we've got the nth partial sum, the same thing that we had up above here. If we multiply both sides by r, now by the way, this notice, because this starts at 0, so if we have n terms, first one's going to be 0 all the way up to n minus 1, so that has n terms. Let's multiply both sides by r, which means we've got to distribute this out here. If we take this whole thing and multiply it by r, we get this guy down here. And now we can subtract this because it's a series, a system of equations now. So if we subtract these two equations, we get s sub n minus r s sub n. Okay. And we get, here when we add all these up, or I mean we subtract it actually, right? All these common ones are going to subtract, kind of like that telescoping series we just saw. Okay, what's left over? Well, we have a minus ar to the n. And doing a little bit of algebra here, we can factor out that a, factor out this s sub n, okay, and we can divide both sides by 1 minus r, and we get this, s sub n equals a over 1 minus r times 1 minus r to the n, and dividing we get this term. Now we can find, we got our partial sum, s sub n, got an expression for it. So if the ratio r is less than 1, so it's like a half or a third or something like that, okay, then this limits here, because remember the ratio is 1/2 or 1/3 or something like that, okay, will be equal here. Now this first part can come out, okay, because it doesn't have an n in it. So the limit of this parenthesis part, well, what's going on there? Well, this is ratio is like a half, so a half to the 100th power is basically going to 0, right? Or a third, or whatever this ratio is. It's less than 1, so this part is going to 0. Okay, so in other words, the inside the parentheses is going to 0, and we're left with a over 1 minus r. So there we have it. So the series converges to a over 1 minus r if r is less than 1, the absolute value. Okay, so if r is greater than 1, then it diverges, because if this is like, if r was 2, this would be 2 to the first, 2 to the second, 2 to the third, 2 to the infinity. This part's blowing up. Okay, so it doesn't converge if r is greater than 1. So now all I've got to do is got to identify that it is geometric, and then we can use that rule. All right, so is this geometric here? Well, again, we are looking for the sum as n goes to 0 to infinity. Actually, could be 1 to infinity as well. Let's talk about that. But whoops, let's write the a r to the n. Okay, so what's going on here? Well, we can rewrite this. N equals 0 to infinity. We can pull that 3 out. And then we're left with 1 over 2 to the n. Okay. Then we're trying to get this into a ratio to the nth power. So we got the 3 hanging out. And how about this? Can we write this as 1 over 2 to the nth? Well, this is 2 to the nth. And 1 to the nth, well, 1 to the nth is just 1. So yes, we can. There it is. All right, so it is now, notice we have a times r to the n. There's a times r to the n. So a equals 3, r equals 1/2. So we ask ourselves, is the ratio between 0 and 1? It definitely is. So the summation of n goes to 0 infinity of 3 over 2 to the n is equal to a over 1 minus r. Well, a is 3. The a value is at 3. And it's 1 minus 1/2, 1 minus r. So that is 3 minus 3 over 1/2. Multiply top and bottom by 2, that equals 6. So there you have it. So that is our limit there. Okay. How about b here? So what is the a value? Well, there's an a value of an invisible 1 if you want. And then the ratio here is 3/2. So will this converge? Nope, it won't, because this will keep growing. Each term will keep growing. And so, because 3 over n is bigger than 1. So this diverges because that 3 over 2 is bigger than 1. And that's how a geometric series works. So remembering this formula is important. Okay, if r is less than 1, and the absolute value of r is less than 1, then it converges to a over 1 minus r. So our goal here is to figure out first if a series does converge or not. And then if we can figure out what it converges to, that's great. But first we got to just decide if it does converge. So here's a couple simple little theorems that we want to remember. First one is the nth term for convergent series. If we know a series converges, then that means that the limit of a sub n, which are the individual terms, must be 0. In other words, if we have some series here, which we can write out like this, okay, if we know it converges, then that means this value a sub n will basically disappear, because at some point we got to be adding on nothing, because remember this series goes on forever. So if we were to write it out forever, then the only way that a sub n can converge is if the series can converge is if the individual term basically disappears. Okay? Now the opposite is not true. If the limit of the term goes to 0, that does not mean that the series converges. Okay, that's not necessarily true. Gotta be careful there. Okay, so we have an nth term test for divergence. We'll use this a lot. Well, if we know that a sub n, the limit of a sub n is something bigger than 0, in other words, if we know the individual term doesn't disappear, then the series must diverge. Okay? So let's figure out if these converge or diverge using those tests. Okay? Not figuring out what they go to, just do they converge or diverge. So it's helpful to write out the first few terms. We have 2 to the 0, 2 to the first, 2 to the second, 2 to the third, so on and so forth. So that is 1 plus 2 plus 4 plus 8. Okay? Now, the question is are these going to 0 or are these blowing up? Well, pretty clearly, the limit as n goes to infinity of 2 to the n is not 0. So in other words, they're not disappearing. So that implies that the series diverges. So it diverges because we're always adding on something bigger and bigger and bigger. Okay? So let's look at the nth term here. What's the limit of the nth term as n goes to infinity, n factorial over 2n factorial plus 1. Well, as we go to infinity, this 1 doesn't matter, so this is equal to the limit as n goes to infinity of n factorial over 2 times n factorial. Well, those n factorials cancel, and we're just left with 1 over 2. So it's 1/2. So the terms are basically becoming a half. Does this converge? Well, it actually doesn't, because eventually we're going to have, we have our partial sum, our nth partial sum, and then we're just adding on a bunch of halves, or things that are pretty much a half. Okay, so if we add on, if we go to infinity here, we're just adding on a half forever, and it's just never going to get smaller. Okay, so we only converge to a certain number if these values go away. So this diverges. So in other words, it diverges if the terms are getting bigger. It diverges if the terms are staying the same. And what happens here? Well, you might be thinking it converges. Let's find out here. Okay, so the nth term is 1 over n. Okay, and so the limit as n goes to infinity of 1 over n is 0. But we got to be careful. That doesn't tell us that it converges. That only works for diverging. All right. So far we have to say there's no conclusion here. Based on the nth term test. Okay. So again, if the nth term diverges or stays the same, then the series diverges. Okay. If the nth term converges to 0, that still doesn't mean that this converges. Okay, got to be very careful, because it actually turns out that this series will diverge. We'll prove that to us very soon. Okay, we'll leave it at that. So we got some basic tests to show us whether a series converges or not, or whether it diverges specifically there. Okay, so that test does not tell us it converges. The test only tells us, the nth term tells us if it diverges. All right, thanks for thinking through some series with me, and hope that helps.